very soon. And we have various projects. You have seen some of them going on. And a strong software team for efficient implementation. So it's a good package, integrated, nice, multidisciplinary package that is going to not only help you be successful. Our placement office is already doing a great job in placing you right. But next is after placement, you need to be successful, right? And you need to reach fulfillment someday, right? That's Maharish's goal, and your goal too. And that fulfillment will come from there. And from that angle, you also need to not only help yourself, but also help other countries, especially the country you came from and other parts of the world. That means you can help us to bring more students so that we can help the world in a better way together. So that brings us to the next slide, which is helping global development. So NLP-based computing will help many more people to enjoy the benefits of the internet and information age in a much more effective and efficient way, and enabling many more people around the world, especially in the underdeveloped and developed world, and help bridging the digital divide and language divide. Language divide means, because of the language, people do not get all the content. Most of the content is dominated by English and Chinese on the internet. And help sustainable global development by focusing on education, innovation, and entrepreneurship. This is also very important because some of you will become innovator and entrepreneur and start companies after working here some time. That is also very encouraging and helpful. Not just working in the company, but working for yourself. And all these are well aligned with MOM's vision. Number one, develop students' total creative potential via consciousness-based education. And we are talking about, multidisciplinary, more complete education aligned with that. Scale up the consciousness-based education globally. So we want to teach, we want to train, we want to share this knowledge of future computing to more people in the world, and you can help. Global development to bring fulfillment to the economic aspirations of individuals and society. Sustainable development to maximize the intelligent use of the environment and world peace. So everything is integrated together, nice way, so that you can relate to it. And if you are interested, you can dig more. It's on the last slide. Some works we have done. And thank you very much. I'm open for questions. We have two microphones here. All right, anyone? Good question?
Professor Khan, thank you. I didn't get the distinction between advanced analytics and data science and big data, and also about natural language processing. What's the distinction between all these things?
Okay, so big data is basically a large amount of data, and you need to have good infrastructures and algorithms for infrastructure, like MapReduce Hadoop is a good infrastructure to deal with big data, right? And then you have other associated engines or software packaging tools like Cassandra and Spark and things like that. So this goes under big data usually. And on the data science side, it goes mainly, although big data includes data mining, as I said, big data and data science is interlinked very well, and people use them interchangeably. But in general, that's what big data is. On the data science, the focus is more on how can you extract knowledge from raw data. So So that involves some processing which belongs to data science as well as to big data. But after processing, initial processing, understanding the data, modeling the data, that normally falls more on the data science side. And that's where you need machine learning, using various approaches, statistical packages, neural network, fuzzy logic, other methods. There are many ways to do machine learning. So that is big data and data science. Now, natural language, so these are all dealing with the numbers, right? Now, numbers is good for computers. Numbers is also good for us, but we not only use numbers. Right now I'm talking to you and you asked me a question, there was no numbers, right? We are using text. So computer does not know how to understand and process this text. That's what is natural language. Programming language is like Java, C++, or whatever you are doing, Python. Good for computers. But we communicate normally, we understand both if you know C++, I know C++, you can communicate via C++, but naturally you communicate natural language, and that's the one this guy does not understand. So how can we make computers to understand our natural language so that we can get a lot more benefits out of the computer? That's what is driving the next generation computer. And that's what is natural language understanding and natural language processing. Does that help you? Yeah? All right, thank you for asking that question.
Professor, may I know what are the available tools for natural language processing if we develop our own system? Say, for example, we use Jade library for multi-agent system in artificial intelligence. Likewise, any tools for this?
Yes, you can use something from Stanford tool. I think this is called Stanford NLP or NLPK. Then there is a core NLP. You search. I would recommend mainly Stanford is pretty rich in doing. Their NER system, name entity recognition system, is very good. So core NLP, Stanford NLP. Then you need to use also other, if you are using parsing, then there are some parsing software. I mean, these days if you type, you will get all kinds of tools. There are a bunch of tools, but more important is what can you do where tools cannot do much. You come up with the algorithm. That's what should be the more focus. But yeah, there are many tools. I can give you more names later on. Yes. Yeah.
You said that there is 20% structured data and 80% unstructured data. If I have a system already in structured data and I want to migrate to unstructured data, how can I do that with low cost and with efficient time and at the same time I cannot lose my data?
So you are going from unstructured to structured?
No, I want to from structured to unstructured.
Structured, you want to go to unstructured. Okay, so you are generating the sentences. That's what you're saying. Unstructured data gave you some result. Sorry, structured data gave you some result. You want to go to unstructured data. So you want to convert those numbers or tables into a natural language. Am I correct? How do you do that? Is that the question? That one is a little bit more difficult, but it's doable because you just have to map. It's easier than semantics, but still you have to map numbers to structured sub-sentences. So suppose you are saying you have a table that says company's earning was X% more than the previous quarter, and they expect 25% more in the next quarter, right? So now you understood it as a human. You can put that into structured natural language sentence. Company, history or company prediction, last quarter, next quarter, following quarter, and then fill them in with the data you have. So you need simple AI rule-based engine, okay? And then you can populate. Any other? Yes.
What we are addressing here is machine learning and natural language processing. I would say that natural language processing is basically depending on speech recognition. and this field is still not mature enough to be dependent to depend on. So basically, if we want to understand what the video, for example, a video of this lecture, if somebody searches about some context of this video, the search engine cannot get the meaning of this video. First, it has to go through speech recognition, recognize the words, and then it has to apply the natural language processing to understand the meanings. And the speech recognition part is still not mature enough to depend on.
Yeah, so very good question. The speech recognition has come a long way, but still has a long way to go, especially when you are in a noisy environment and you say something machine does not understand or understand wrongly and it assumes something, does something which you don't understand. So natural language has two types of input. One is the speech recognition, the other is typing. So one solution is, if you are in a noisy environment, your speech recognition is not working, type natural language will process. B, with semantics, you can understand broken words. So with the semantic engine, even if you are talking with speech recognition engine that is not as good as you expect to be, the overall rate will be better. But the problem is still there. It will be there, I think, with more semantics and more. Right now, the speech recognition engines are hidden Markov model based, and which is very good algorithm. But still, it is probability. I mentioned it, but I did not answer it. You know, probability and statistics are great, but they are great based on number manipulation, right? And when you manipulate number, there is not much semantics. Only semantics is whatever we understand with numbers, right? Now, when you're trying to understand natural language, semantics is so difficult, right? We cannot use numbers to represent the semantics. So, statistics can give you, this much. When you are trying to understand complex things, you need to use machine learning because it does not use any overall average or distribution and things like that. It tries to learn based on the data pattern. So it can give you a little bit better than what statistical packages does. Especially statistical machine learning, which is the hidden market model, has done very well on two applications. One is speech recognition, another is genome, genome coding without hidden Markov model, which is statistics. Okay. We do not have it by now. So these are great. Where it is not good is where you try to learn specific pattern or specific model. And then, don't get me wrong, don't assume that if you just have great machine learning that will solve everything. Who are doing machine learning algorithms? It is us. So it is the same thing. We are trying to put some equations. Instead of putting equations in a form that can address a bigger space, we just do it incrementally in machine learning. Incremental machine learning. If you don't do incremental machine learning, then it will be again gross learning. Gross learning is not very good. Incremental learning is better, but it's not as good as here. So we need much better machine learning algorithms as well. But again, we are not stopping, world is not stopped, right? Everything is moving, so we are moving like that. But set the expectation right. But right now, as I say, if you focus on these things, you can advance very well in the industry. And the challenge will remain and you will keep on going. Yes?
As a scientist who dive really deep into this topic, in your opinion, what year we will have a human-like thinking AI?
Very good question. And I don't know the answer, but what I know though, how many of you know singularity theory or what's the name of the gentleman? The MIT gentleman? Anybody know? He wrote a book called The Singularity is Near. I just forgot his name, very familiar, well-known guy, gentleman. So he's saying 2040, we are going to reverse engineer the brain. Okay. And there are two schools of thought. One school of thought thinks that yes, you will be successful. Okay, Ray Kurzweil. His name is Dr. Ray Kurzweil. And I personally don't believe it. I'm on the other side, where the more we will dig to our brain, the more we will know how much we do not know. And so it is going to be a very complex thing, and I don't think we will not understand our brain to the level we are looking for. I don't think it's possible. This is my opinion, but I may be wrong. So AI will advance. I don't think it will ever replace human intellect. It will advance in a manner where it will do more number crunching and integration with natural language processing. But we will still be ahead in overall thought process, understanding, and so on. Unless we make biological computers, biological-based computers, then the story will be different. But silicon-based with our algorithm, one human architecture, for example, is great, but it's not good for natural language, for example. Right? Not everything is good for everything. Right? It evolves, yes.
I'm just curious to know if there is any AI, freely available AI application that can capture the human facial expressions and make sense out of it.
So you're talking about face recognition?
Yeah, any application that can capture the human facial expressions and gestures, and then like a human being that can make sense out of that can make interpretation, inferences, etc.
Yes. MIT Media Lab is doing some good work, wearable computing and what you say. Stanford is doing a great job in collaboration with Google to recognize faces, and with deep learning that they came up with a couple of years ago, they have made good contribution to that. So that field is going well. Now we need to recognize everybody nicely. That will take more time because the features we have used in this talk for natural language, we need similar semantic features for our face, for objects, and those are in a sense, a little bit more difficult because we know how to define our language semantics. So we can make something and explain it to computer. But image, semantics for various objects and shapes and all those things are not that simple.
Just one more question.
Yeah.
Do you believe that intelligence can be materialized? Every expressions of intelligence can be materialized, can be expressed through the applications and stuff like that.
Okay. Before answering that, I just wanted to add to your previous answer that although I say face itself is more difficult, but in a sense it is also less difficult because in natural language we have sequence of sentences, sequence of words, which gives us sequence of things to absorb to find a meaning. That is not necessarily the case for face recognition, where you just recognize someone's face. So from that standpoint, it's easy. Now, to answer your next question, I'm glad that you were asking it, which is a little bit more philosophical. Intelligence we have, as I said here, my belief is that we will not be able to reverse engineer brain, and we will not be able to make machines that will be as intelligent as us until we can use probably some biological machine, which might be possible. Now that we know DNA, we need to understand the DNA and so on. And someday we might be able to create a cell. And if we can create a cell, we might be able to modify it nicely and train it so that it will become intelligent. But I don't think it will ever be intelligent like us for multiple reasons. One is we are designing it. I don't think nature gave us the capability to design something better than us. Secondly, if you go to basic science and consciousness-based education, the pure consciousness, is it's not necessarily with you, you can connect. It's only pure consciousness internet, you can say nature's pure consciousness internet, wherever it is. Right? So the real intelligence, as I said, this is hypothetical and philosophical, but we may not carry intelligence, we get connected. So we don't know how to connect if you can make some machine like that. We don't know how to connect those intelligence, or understand those networks and things like that. So I don't think we can make anything which will be more intelligent human. If we use biological things, we will do, but still it will be behind. It will be less capable than that.
Thank you.
Yes.
Yeah, thank you. I find this topic really interesting. I noticed in your presentation that you mentioned some of the limitations of the current web, for instance, lack of semantics. But I understand there are some W3C groups that are actually working on semantic web and things like web ontology languages. So I wanted to ask, what are the limitations of that, and how does the serverless system improve on that existing work?
Okay, good question. So semantic web is a great idea that came from MIT researchers, and it is good. It is good to handle structured problems. For example, in a website, you have tables, frames, and things like that. How can you quickly get some information from that and provide it to the user? But if you try to make intelligent internet that I show, where you can query anything in natural language, then semantic web cannot handle it, because semantic web would need to define the meaning of everything, and then there will be combinatorial explosions, and it will not be possible. So any problem you solve, you have to go to the root of the problem, or root cause, and try to solve the root cause. Otherwise, you will be just replicating the same thing, in multiple areas.
Another thought that just crossed my mind based on your answer now. Now, if we're looking at machine language, natural language processing to help us in this area of bringing home in more, to enhancing our solutions to finding appropriate data as we need. What about, like you said, combinatorial situation, combinatorial explosion, when we're trying to do natural language? For more natural language, for instance, do we know all natural languages that exist, or are we only limiting ourselves to English and maybe Chinese or Arabic?
No, all.
So all possible natural languages.
Yes.
So could there be a situation where we have as many natural languages as there are just too many, and we have the same kind of situation?
But again, I will go back to the original issue, old issue. No matter what languages you pick, the semantics style is same, right? So semantics will be there. Their grammar may be different. Their semantic format may be different, but still their semantics is there. We are human. Our brain here, everything is same. For example, when you think, we probably do not use a particular language. Whether you are Chinese or Japanese or something, when you are thinking level, we are doing processing at a much higher level. Without talking or without using any language, we can process things. So now, will Sebla, address all of them? No. As I said in answering his question, we are just going one step up. If I say we are becoming like human, I will lie, and that claim is invalid. Right? We are incremental. I don't think we can jump. Our brain was designed to be incremental. We cannot jump, because if you jump A, it is impossible. B, even if somebody could jump, the society will fail. Right? We have a very good integrated, stable system that is advancing with its own nature's rate. If we try to break it, I think we cannot do that, and also it was not designed to be jumping like that. Yeah. Our human brain, we have about 100 billion neurons and 1 trillion connections. Okay, and we learn on the fly. One of the main problems today we have, for example, and that's related to the industry, right? We on the spot, on the fly, we can switch context, right? We can deprogram ourselves. So that's why we are much better than program we write. When we write a program, it cannot switch based on the situation. it got stuck, and that's it. Right? So our next goal will be write a program that can switch, reconfigure using some machine learning. And related to that could be, which is possible, probably coming within 5 years. That is, instead of Java or Python or something, we say naturally what we want and convert that natural language into a programming language, then use compiler to finally go to the machine language. Just moving up the same way we have done one more level. Yes.
We know that every expression, every feelings, every conversation comes from our mind. And yeah. And what is the guarantee that NLP fulfill all our expressions? Did you get it?
No, I didn't.
Actually, what I'm talking is every expression, every communication, every talking, each and everything comes from our mind, right? And you know that my mind is broad. We cannot win the mind, you know. And so the NLP is going. How the NLP fulfill our expression?
If you have a thought, yes, NLP can fulfill the expression in you, but not in a computer. Is that what you're asking?
No. What I want to say is, can NLP guarantee all our expression will be natural language processing? Guarantee all our expression will be computerized?
Oh, you mean, will NLP understand your natural language where you have different expressions? Yeah. Well, not if you have all the words. If you have all the words, it will understand the meaning. If you are asking me like you are very happy and you express something in your face, NLP will not understand the face, like for example. But if you give a sentence that is text and it has all the words that a human will understand, then NLP will understand. That's all.
Sometimes what happens is when we talking something, but in the sense where sometimes what happens when we talking about some sentence, but our meaning is sometimes different, you know.
Oh, that would be
in the sense, how NLP guarantee that what I am expressing the sentence is right, what I feeling.
Right. No, again, what I said is, we calculate meaning of sentences based on meaning of words, meaning of paragraphs based on meaning of sentences. So if you give me an article, it will understand the context of it based on the word knowledge it has learned. Not to the same level as human, because we will not be able to give same word knowledge to a computer that we have. So there will be always gap. But you can make a cut and make a smaller application where you are happy enough with that application that computer can understand or will understand. Does that make sense? So if you expect that you are upset and it will understand it, that's not going to happen, right? You have to say I am upset, then it will understand that you are upset. Have I answered your question or? Okay. So I guess it has been great. In fact, one comment, I was very impressed with all these questions I didn't expect. So that was good that I somehow charged up a little bit, you guys.